We're going to graph y equals the secant of theta over 3 plus pi over 6. Now, in this example, we're going to need to factor out the 1/3 that's the coefficient of theta. So this becomes y equals the secant of 1/3 times theta plus, I'm going to come off to the side. When I factor out the 1/3, I divide it out. So when I divide it out of the pi over 6, we get 3 pi over 6, which reduces to pi over 2. So our phase shift is negative pi over 2, which means we're going to be going left pi over 2. This b value is going to affect the period. The period is 2 pi over b, which is 2 pi over 1/3, which is 6 pi. Because we're graphing the secant, we're going to first plot all of the critical points for the cosine graph. So the cosine graph, we're going to go right pi over 2. Here I go again, right pi over 2. Left pi over 2. We're going to go left pi over 2. Right here, left pi over 2. Actually, I'm going to do this in green. Left pi over 2. And cosine starts at its maximum. And then 6 pi later. So we'll have 5 pi. And then 6 pi would be probably right about there. But we need to go just a half a pi before that. We're going to end at the maximum. So cosine starts at the maximum. At the end of the period, it's at the maximum again. And then halfway between, so halfway between would be at 2.5 pi. We're going to be at the minimum. And then halfway between the maximum and the minimum, we're at the midline. So I'm going to continue that pattern as much as I can. So here's the cosine graph. So this is the cosine graph. You can probably hear that tapping. Now where the cosine graph crosses the x-axis or the midline, we have the asymptotes. And then at all of the minimums, we have the U's that are opening down. And at all of the maximums, we have the U's that are opening up. And we should be careful not to cross over the vertical asymptote. And that's about all that we can graph there for that graph. So now we'll try another one. Here's one to try. See if you can do this one without having to follow along. So see if you can maybe be a little bit ahead and then pressing pause so that you can give yourself some time to try it out, and then press play if you get stuck or if you want to see the answer. So in this case, I'm going to factor out the 1/2. And that's going to leave me 0 minus 2 pi over 3. So this tells me that I need to shift my graph right 2 pi over 3. So right 2 pi over 3 is going to be right about here. And our period for this function is going to be 2 pi divided by 1/2, this 1/2 right there, and that becomes 4 pi. So 2 pi over 3, I'm going to come down over here, 2 pi over 3 plus 4 pi, so 4 pi would be 12 pi over 3, is 14 pi over 3, which is about a little bit more than 4, right? So it's 4 2/3. So 4 2/3. So we're not going to be able to get a full cycle to the right. This is 4 pi. And I need to go a little bit further out there. I can kind of guesstimate that that's where maybe the 14 pi over 3 might land. But I can still graph this. To the left, 2 pi over 3 minus 4 pi is negative 10 pi over 3. And that's negative 3 1/3 of a pi. So we're talking probably right about here. Now secant starts at its maximum. So it starts at its maximum. Actually, it comes from the cosine graph that starts at its maximum. And then halfway between the period, it's going to be at its minimum. So halfway between the period is probably going to be right about here. And then it's going to be at its maximum 4 pi later. So what I'm saying is this horizontal length right here is 4 pi. And then halfway between, we're at the minimum. And then we're at the midline, just right about there. And our midline right about there. So we've got this happening right here. And then we've got our vertical asymptotes for our secant graph, and they occur where the cosine graph crosses the midline. And then we've got u's opening up, and u's opening down, and then opening up. And we're going to do something like that, and then we would have another one over here, and then when we have another one over here. And that's pretty good. It's a little bit more challenging to graph on a fixed graph that's like that. So if I were graphing number 8 from scratch, I would do something like this. I would say this is 2 pi over 3, and then 4 pi later, I would have 14 pi over 3. And somewhere in the middle, I would have 8 pi over 3. And how I got 8 pi over 3 is that the distance from here to here is 12 pi over 3, which is 4 pi. Half that distance would be 6 pi over 3. So I would come up with that, and then half that distance would be 3 pi over 3. So 3 pi over 3 would give you a 5 pi over 3 right here, and 3 pi over 3 would give you an 11 pi over 3 right there. And then I would graph my max to my max, and then 8 pi over 3 would be a min, and then my 5 pi over 3 and 11 pi over 3 would cross the midline. That's the cosine curve. And then from that cosine curve, you create your vertical asymptotes, and you've got your u's that are opening up and your u's that are opening down. So a little bit easier when you make your own axis when it's these unconventional phase shifts that don't fall with a pi over 4, pi over 2, or pi.